Okay, we're going to graph reciprocal functions today. You need to be able to find the domain and the range of each function, and the main thing that you need to pay attention to is the denominator. So there are restrictions to the denominator, which restricts the domain. If there's a variable in the denominator, then there is a restriction to the domain, always. So there is a variable in this denominator. To find out the values that x cannot be, we would need to factor the denominator and then say what makes the denominator 0. So x plus 4 can't equal 0, and x minus 4 can't equal 0, which means that x can't equal negative 4, and x can't equal positive 4. So that restricts the domain will be all reals except negative 4 and 4. Okay, you have to have a way to write it that's clear and be able to tell me what the exceptions to the domain are, what the domain is. The second one, you can factor out a monomial factor of x. So x cannot equal 0, and x plus 7 cannot equal 0, which means x can't equal 0 or negative 7. So for this rational function, the domain would be all reals except 0 and negative 7. Now, you can write that in interval notation. Uh-oh, I should have wrote an ampersand or something. I don't want it to look like a point in any way, shape, or form. 0 or negative 7, another way to say it. If you were to write this in interval notation, this would be kind of a pain because it go from negative infinity up to negative 7, union with negative 7 to 0, and then union that with negative 7 to infinity. I'm not going to make you write it in interval notation, but I will note for you that this letter, have you ever seen that maybe in a book? That means all real numbers. If you want to kind of abbreviate this a little bit, that's okay. Yes. Why would it be? Say that again. Oh, I don't know. I made a boo-boo. Thank you for saying something. I don't know how I put that there. It should be 0. Thank you. I made a boo-boo. I know better than that, but yes, you're right. Absolutely. Because it should be connected, you know. Yeah, it just said 0 to infinity, not negative 7. Thank you. I was a little distracted in my mind, apparently. Now, I had some students, actually what I was thinking of was what a student had asked me in my second hour class. And I thought it was a good question. Did anybody think about there was an x in the numerator? She was asking me, well, why can't I cancel that x with that x? Well, you could if you were simplifying it, but we're not simplifying it right now. So we have to pay attention to what the original problem has in its denominator to find the restrictions, okay? So do not try to simplify first and then find your restrictions. And this one would be x minus 7 times x plus 3 in factored form. So the domain would be, you can write that R letter if you like, reals, except, and then you still got to write except, my pen's acting weird, 7 and negative 3. Okay, and for number 4, it's all reals except, I don't know, I tend to keep writing the words, all reals except negative 4. All right, now we're going to start to look at their graphs. The type of graph is not moving. Something has frozen on me. Okay, let me try again. Oh, it's just taking its time. And it went further than I wished it to go. All right, this is where we are. All right. The parent function is called, today is called the hyperbola. we've done parabolas. And now I remember a student of mine long, long ago in Algebra 2. It wasn't honors, but we were just learning about parabolas and hyperbolas. And I asked what the names of the things were, and she wrote perbola and perbola. It was kind of funny, but I guess you had to be there. All right, so a hyperbola is a graph of 1 over x, y equals 1 over x. And what it looks like is, okay, you've got a big chart, right? And how come I'm not on the chart now? Because I guess I hit that button too many times. Now I'm getting where we're supposed to. Sorry about that, guys. This is the graph of a hyperbola. H-Y-P-E-R, bola. All right, the hyperbola is the parent. This is the parent. And all other are transformed from that graph. And what does the A do? You might remember, I hope, it stretches vertically. Stretches the graph vertically. My handwriting needs something to be desired today. The K shifts it vertically. Vertical shift, up or down. And H is a horizontal shift, just like all the other graphs we've been doing this year. Okay, this basic hyperbola looks something like this. It has a little loop in quadrant 1 and 3. That is the graph. I didn't on a very nice looking one, so I'll do it in red so you can see over it. So you can tell from what it looks like there that it has asymptotes. All right, so after it was Valentine's Day today, this time, and I just got some chocolate strawberries. All right, what we need to know about this graph is that the domain we already talked about, that would be all reals except, well, domain for the basic parent graph. Domain would be all reals except 0. Can't have 0. And the range would be all reals except 0. That's what that's saying. All non-zero real numbers, all non-zero real numbers. We're going to write it more like that instead of writing all non-zero real numbers. All right, so what else we need to know about is it has some asymptotes. The asymptotes are the x-axis, which is y equals 0, and I'm going to call this your HA, horizontal asymptote. And the y-axis is also an asymptote, and that would be your vertical asymptote, and I'm going to tend to say the VA, vertical asymptote. Now, and this, another way to write this is here is that x cannot equal 0, and that means you have a vertical asymptote at x equals 0. This one, y can't equal 0, so you have a horizontal asymptote at y equals 0. Now, we talked already about what h and k, etc. does. So what if you have transformed one of these things, which means it's been either stretched and shifted horizontally or vertically? You might want to know that the vertical asymptote will be x equals, what do you think? H, okay? And the horizontal asymptote will be y equals k. That's if it's in this format. Okay, where you can see the H and the K transformation. There are no x-intercepts, but there might be when we get to these, because they shift. So if they're sliding around, then you're going to get some intercepts. You have to look for the intercepts. Now, I thought I'd bring up, what do you think this looks like? Y equals negative 1 over x. Okay, now I'm going to preface this with the fact that you have to be able to do these graphs without a calculator. You will have a no calculator quiz. You will have to be able to do it. And I'm teaching it today. I'm not even bringing up the calculator till the very end. No calculator quiz is the next quiz. Okay, so this isn't that bad. You're going to find out in a few minutes. It's really not. What do you think this did? You just told me this one's in first and third. So this is probably in the second and fourth. That's all it does. It reflects it over the x-axis. All right, let's get on to seeing how to graph these and how to figure it out. I'm going to show you a very easy way to get them done but without a calculator. All right, you got your parent graph, 1 over x. That's the first one, and that's this one right here. It's already been graphed. Okay, what do we see about it? If you put in 3 in here, you're going to get 1/3. If you put in 2, you're going to get 1/2. If you put in 1, you're going to get 1. If you put in a half, you're going to do 1 divided by a half, which will mean you'll do 1 times the reciprocal. So that's going to be 2. If you put in -1/2, you get -2. If you put in -1 for x, you would get -1. -1/2 would be the next one, and -1/3 would be the last one. You do not have to plot this many points to give me a sketch of your parabola. But let's just see where these points are. 1, 1, oh, there's that one. -1, -1, there's that one. It's in the first and the third quadrants. 1/2, 2, 1/2 is right there. So I'm going to need a minimum of 1 point in each quadrant. And that's going to depend on what the numerator is of your irrational function. Okay, so let's check out this next one. If you were to, it's asking us to identify the asymptotes, give the domain and the range. So the asymptotes, the vertical asymptote is x equals 0. The horizontal asymptote is y equals 0. So for this one, the domain is all reals except 0. And so is the range. Okay, and again, I could show you how to write that in integral notation. I don't think I'm going to be requiring that much, so I'll skip that for right now. This one, you're going to see that you have an h value here of 1, which means your vertical asymptote is, I don't know why I wrote an equal sign. I prefer that you not write an equal sign there. Your vertical asymptote would be x equals 1. And if you notice here, this is where it is. And you're going to be required to show them on your graphs dashed. Okay. So over here on the first one, I would have dashed the x and the y axis. You can use a highlighter if that's what you prefer. I kind of made a mess of that one. This one, your horizontal asymptote is y equals 0. Those are the asymptotes. So the domain here is all reals except 1. And the range, all reals except 0. Heard a lot of people getting out highlighters, which is just fine. Okay, can I go now? No, wait a second. What did that -3 do to this graph? It stretched it. Do you see how it's kind of stretched away from the 0, 0? Okay, it pulled it outward a little bit. It made it go up. This was tighter in towards 0, 0, where that -3 also flopped it from not being in 1 and 3, but 2 and 4. Okay, and then that -1, that was our shift horizontally. Okay, try another one. So let's make a prediction about this graph. This graph, you have an h of not 3, but -3. Okay, all right, that tells me my vertical asymptote is going to be x equals -3. So what does the a do to the graph? We already said if a is 0, not 0, is bigger than 0, then we're going to be in quadrant 1 and 3. Now, I don't want to imply that I'm saying that it's really in the quadrants completely because of the shifts. All right, so I'm kind of using that term loosely because you're not truly in quadrant 1 and 3. But you get what I mean by that as far as the symmetry of the graph, the way it's going to look. All right, but it also stretches Y. Stretches it vertically up. That's your stretches the Y value. Trying to make that abbreviated a little bit. And if A is less than 0, you're going to be in quadrant 2. So I'm going to put quotations on that because I'm technically not saying something that's absolutely accurate or mathematically correct. Quadrant 2 and quadrant 4. All right, and which is basically a reflection, okay, in the x-axis. It's a reflect over the x-axis or reflection in the x-axis. Okay, I guess I didn't have to write the stretches there. The absolute value of A is what stretches the Y's. Okay. By that factor. So like if it's 3, it's stretching it by 3 times. What is the H to the graph? Well, we've already discussed that so many times. That's a horizontal shift. Okay, and you know it's up or down, and I hope so. Vertical shift for the K value. And I'm going to write arrows. You got to remember, horizontal is going like the horizon, the ground, and vertical is going up and down. Okay, and what are the asymptotes? Well, the asymptotes, the horizontal asymptote, which I'm going to use HA, will be Y equals K, and the vertical asymptote, and I'm going to use VA, will be X equals H. And if you need to write horizontal under there and vertical, feel free. All right, let's get this graph. Let's talk about those asymptotes again. All right, the -3 is your X or vertical asymptote. So I'm going to dash it. Oops, I just stuck that in the wrong place. It's a -3, Heimer. Okay, and then the K value tells me I have a horizontal asymptote at Y equals -1. So I'll dash that in. Now, here's how you decide what to pick, because you might be going, well, I don't know, what am I supposed to plug in? Well, what makes sense? Numbers that will make this easy to figure out. And I can tell you what, if you know where your asymptotes are, then you've got a guide for which numbers to plug in. So my asymptote's at -3. So I'm going to plug in a value to the right of my asymptote, which is -2, and one to the left of it, which is -4. I can't plug in the asymptote number. I'll be undefined there. So if I put in -2 for X, the denominator will be 1. That will give me 2 minus 1, which is 1. So -2, 1 is a point on the graph. If I plug -4 into the equation, -4 plus 3 would be -1. I would have -2 then plus -1, which would give me -3. I'm doing this in my head. I think that if you need me to show it, I can plug the numbers in, but this is what I did. That gave me 2 over 1 minus 1, 2 minus 1. This is where I got my 1. If I plugged in -4, that would be 2 over -4 plus 3 minus 1, which is 2 over -1 minus 1. That's where I got -3. Okay? Now I'm going to plot that, -4, -3. Now I would like to get, I'm going to go for 2 more points because this one has a 2 in the numerator. I definitely can get 2 in each area. That would be nice. So I'm just going to go one more step to the right of my vertical asymptote and put in -1. and to the left of it, negative 5. Now, in my head, I'm just going to do in my head, negative 1 plus 3 is 2, 2 divided by 2 is 1, 1 minus 1 is 0. Plug in negative 5, you would have negative 2 in the denominator, 2 divided by negative 2 would be negative 1, and negative 1 minus 1 would be negative 2. All right, let me plot those. Negative 1, 0, I just found an x-intercept. And you'll say, well, you said there weren't any. Well, that's only for the parent graph, okay? The asymptotes have shifted, so now there could be an intercept. Negative 5, negative 2. And now I'm going to sketch my graph. So you're going to have to show proper end behavior. Come try to hit the points and run along the asymptotes and put arrows on it. Okay, next one. Identify all the parts of each graph. All right, we got to turn your page, I believe, for number 4. I see I have an h of negative 1 and a k that is 2. That tells me my vertical asymptote, or VA. I know it says the word vertical asymptote. I just want you to know what I'm talking about when you see a quiz and it says VA, okay? Right, so it's shorter and I'll have a little blank for it or whatever. Vertical asymptote, x equals negative 1. Horizontal asymptote is y equals 2. So I'm going to go put them right on the graph. X is negative 1, y is 2. All right, so I got that dashed in. And then I see the stretch of 4, so I'm expecting this to be able to find some decent points in these graphs. The domain's going to be all reals if you want to use that big R, except, I'm trying to remember to use that, all real numbers except negative 1. And the range, all reals except 2. Or you can even write x can't equal negative 1, y can't equal 2. All right, here we go. Let's get a graph, make a little t-chart. I would like to see that on your paper when you do the graphs. I have a vertical asymptote of negative 1, so I'm going to put in 0 and negative 2. That's how I'm going to start. If I put in 0, for x, I will get 4 over 1, which is 4. 4 plus 2 is 6. If I put in negative 2, I will get negative 1 in the denominator, giving me negative 4 plus 2, which is negative 2. 0, 6, I'm going to go ahead and plot. Negative 2, negative 2. And then I'm going to say, well, I think I'm going to go for a couple more points. I'm going to go to the right again to 1, and I went 2 to the right of my vertical asymptote, and 2 to the left will be negative 3. If I plug in 1, I'll have 4 divided by 2, which is 2, and 2 plus 2 is 4. So 1, 4 is a point. Oops, kind of made that a little bit big. Oh, well. And if I put in negative 3, I will have 4 divided by negative 2, and that's negative 2. So negative 2 plus 2 will be 0. Okay, so I found an x-intercept. Now I'm just going to sketch along my asymptote, show the end behavior correctly, arrows on there, make sure you have arrows, pass through those points, and then come down and run along your asymptotes. Not that big a deal to do without a calculator. You will be allowed to have a scientific one if you want to do some of the plugging in with your calculator, but you won't be able to use a grapher. So if you feel you really need to have one of those and not doing them in your head, then you may bring in a scientific. Number 5. I have an h value of 1 and a k of negative 3. which tells me my vertical asymptote will be x equals 1, and my horizontal asymptote will be y equals negative 3. I'm going to put those on my graph. I think because those are asymptotes, they do our restrictions to the domain. So the domain is all reals except 1. X can't equal 1. And the range all reals except y cannot equal negative 3. I do want you to, if you're going to use that capital, you need to say something about, it's the range and domain, or have it involve x and y, respectively. All right, P-chart. What am I going to plug in? All right, 2 and 0 or 0 and 2. Doesn't matter what order. Okay, if I put in 0, I'm going to get 1 divided by negative 1. So that'll be negative 1 minus 3, which is negative 4. If I put in 2, I'm going to have 1 divided by 1, and that'll be 1 minus 3, which is negative 2. 2, negative 2. Looks like I'm going to be in the position I expected. Now I'm going to tell you right now, whatever else you plug in, you're going to start getting fractions. And that's because this is a 1 in the numerator. There's no stretch away from where the asymptotes intersect. And so everything else is going to be icky. So this is the time when I would say go ahead and just graph it, because you've got a good point, an accurate point in each area, and you can get the shape that it really is simply because it's so tight to the asymptotes. If you have a numeral that's larger than 1 in the numerator, I would prefer that you get 2 points in each group area. Okay. Minimum 1 accurate point clearly plotted. All right, this is number 6. We're graphing it on the left graph. I got another one with negative 1, which means I'm not going to have a lot of nice points to plug in. But I can see the domain excludes 3, so all reals except x cannot equal 3. And the range, all reals except, well, what can't you have? There's no k, so it's got to be 0. Except y can't equal 0. The vertical asymptote is going to be at x equals 3, and the horizontal asymptote is going to be at y equals 0. So I am going to go ahead and dash my x-axis. You can highlight, and then put a vertical at 3. I didn't need to put arrows on them. I didn't have to. I'm going to make a little T-chart. I have a negative 1 up there, so I'm not going to be putting a whole lot in. I have put in 2 and 4. Plugging in 2, we give negative 1 over negative 1, which is 1. See how close to the intersection of the asymptotes we are. I'm guessing this is going to be right here, right? You see what I mean by the symmetry? So if I put in 4, I actually would get negative 1 divided by 1, which is negative 1. So I was right about where that's going to be. Run along your asymptote. And make sure you put some arrows on there. And if you show your asymptotes and you kind of bump them like I did, it's not a big deal because you show me you know where they are. Okay, so I think a couple more, and then we'll be done with our examples. All right, domain, all reals except 2. X can't equal 2, and all reals for the range except y can't equal 1. vertical asymptote is going to be at x is 2 and the horizontal at y equals 1. Am I going too fast? Anyone? No? All right. All right. Little t-chart up. I've got a 1 in that numerator again. I'm not going to be able to get many points. Most of them are going to be fractional. So I'm going to put in 1 and 3. See, if I put in 1, I'll have -1 on the denominator. 1 divided by -1 is -1 plus 1 will be 0. I'll do that in a different color. If I put in 3, I will have 1 in the denominator. 1 over 1 would be 1 plus 1 is 2. So 3, 2. If you're noticing the symmetry, you can find your other point pretty fast. Don't make sure that you are showing. Now, notice that there's going to be a y-intercept. That might be something I would like you to be able to tell me. So that means you would stick in what for x? If you're going to find me the y-intercept. 0. Okay. That would be -1/2 plus 1, which is +1/2. 0, 1/2. I could show that y-intercept. Oh, I made a mess. Y-intercept is at 0, 1/2. All right, last one. Number 8. Oh, another 1 in the numerator. Not going to have too many points to plot, but this time x cannot equal 0. All reals except x cannot equal 0, and the range, all reals except y, I wrote that kind of weird, y cannot equal 1. Vertical asymptote, x equals 0, horizontal asymptote, y equals 1. Oh, got sloppy here in my haste. Haste makes waste, wasted time. Okay, putting in, I think I'll go with -1 and 1. That'll give me -1 will give me 0, and putting in 1 would give me a 2. Okay. All right, your assignment is no longer, does not look like this anymore because I made you a new worksheet. So this was just what I did second hour. And now I put in all the stuff for you. Okay, so you can get started on your book assignment.